Hello, hello. Hello, hello. Welcome to everyone. This sessions for Andhra Pradesh Vidyut AEE, that is Assistant Executive Engineer. Okay, and in this session we discuss almost all the PYQs in 2019 set, different set, and 2014 also. Okay. So if you face any difficulty in the session, like in concept or in any other relevant things, okay, then you discuss with me. See, this is our first question in 2019 set 3. The gate triggering circuit shown below has the specification IG minimum equal to 100 milliampere and VG minimum equal to 2 volt. Means this is IG. G indicate the gate. Here G also indicate the gate, means gate minimum value of gate current equal to 100 milliampere and minimum value of the gate voltage is the 2 volt. This is the meaning of that specification. See, this is our standard circuit. This is our anode and this is cathode terminal and this is the gate. This is the gate. This is the gate. See, if we want to determine the V triggering, see, in simple terminology, if this current is I, okay, and this is the gate to cathode voltage, this is the gate to cathode voltage, which is given as 2 volt. This is given plus minus 2 volt. We apply KVL in this loop. So V triggering equal to this I into 30, that is 30I, okay, and plus this 2 volt. This is our final answer. But here our agenda is finding the value of I. Okay, so how we can determine this I with the help of this data? Please solve. We give you 1 minute. Okay. You tried? Tell me, dear, what is the answer? Okay, see. If this, here we assume the current I1, here we assume current is I2. So when we apply the KCL at node A, so what is the value of I? See, what is the value of I? This is the equation number 1. And I equal to I1 plus I2. Okay. What is the I1? See, I1 is the current in the gate. Okay. Gate signal, and which is given as 100 milliampere. See in the question, 100 milliampere. When it converted into ampere, then this is 0.1. Okay. Plus I2. I2 means current this in this 30 ohm resistor. If we want to determine current across the resistor and voltage is mentioned, then we apply I equal to V by R. V is the 2 and R is the 30. So what is this value? See, 0.1 plus 1 upon 15. Okay, this is the I. Putting in this expression, or we can say we not solve this because when we put the I, this value in this expression, then automatically this 30 is cancel out. So VT equal to 30I. What is the I value? 0.1 plus 2y30, okay, and plus 2. Multiply 30 inside. This is the 3 plus 2, okay, and plus 2. So this is 2 and 3 and 2, 5 and 2, 7 volt. This is our final answer, and this is your systematic simplest explanation. Any doubt? Tell me if you face any difficulty in this question. Okay, this is our solution. Now, second question, and this is explanation also we mentioned here in the typing format, okay, which you prefer. Next question. A three-phase fully controlled means three-phase, and this is also very important, fully controlled rectifier fed from 200 volt three-phase 50 hertz supply is fired at alpha equal to 45 degree. The average output voltage is, this try simple numerical formula wise. Okay, see, what is the average output voltage formula? VO average means average value of output voltage. This is three-phase fully controlled. Then 3 VML upon pi cos alpha. Okay, cos alpha. And VML is the maximum value of the line voltage. Okay, so the given values in the three-phase system are always line value. If not mentioned, if this is the phase or line, then by default we assume this line. Putting the here, but this is the RMS. Then we find the maximum, multiply by √2, and what is the value? 200 upon pi cos alpha, and alpha is the 45, and cos 45 1 by √2, 1 by √2, √2 cancel out, this √2 and this cos 45 1 by √2 cancel out. Then what is we get? 3 into 200, 600 divided pi, and this is the voltage, this is the voltage, 600 by pi. So what is our answer? 600 by pi. See, and tell me if you face any difficulty. All is clear na? Now next, third question. This is our formula. Okay, here we putting the VL, mean this is the line value, and √2 mentioned separately. See, this is the very important question. The following phasor diagram represents fundamental components of voltage and current on AC side of a three-phase controlled bridge rectifier. The mode of operation is rectifier, inverter, okay, or any other. Tell me. See, this is alpha. This is the alpha, and the value of the alpha is 90 greater than 90 degree. Okay, this alpha is greater than 90 degree. And what is the average output voltage? VO equal to 3 VML, 3-phase full control rectifier, pi cos alpha. And when alpha is greater than 90, then this VO is negative, means power VO IO is negative, means power not transfer from AC to DC. Okay, AC to DC, power transfer back like DC to AC, and this is the inversion process. Okay, beta. So our answer is inverter. So what is the proper solution here? See, three-phase control bridge rectifier from the phasor diagram, VAN is along the positive horizontal axis and the input current IN is in the third quadrant. So the phase angle between the voltage and current is greater than 90 degree. Formula used, P equal to VI cos phi. For rectifier, P greater than 0. For inverter, P less than 0. Okay. And here phi or alpha greater than 90 degree. So cos phi less than 0, that is the negative. Therefore, P equal to VI cos phi negative. Negative power means power is flowing from DC side to AC side. Hence, the converter is operating in inverter mode. So correct answer is inverter. Okay, guys. Next. And these questions from the 2019 set 2. See, the main reason for connecting a pulse transformer at the output stage of the thyristor triggering circuit is to provide electrical isolation. Yes, this is the right, I think. Okay, next. Reduce the turn on time of the thyristor. No. Avoid the spurious triggering of the thyristor due to noise. Amplify the power of triggering pulse. Tell me the answer. Yes. Provide isolation. Yes, simplest questions. This is the explanation. A pulse transformer is connected at the output stage of a thyristor triggering circuit mainly to provide electrical isolation between the control circuit and power circuit. It also helps in coupling the gate pulse safely to the thyristor gate. Correct answer 1, that is provide electrical isolation. Okay. Next. See, it is required to drive, fifth question, it is required to drive a DC shunt motor at different speeds in both the direction, forward and reverse, and also to brake in both the direction. Which one of the following would you use? Okay, means reverse motoring and forward motoring, reverse braking and forward braking. In all the reason we use this type of converter. So which one you preferred? Tell me. Option number 1, full control thyristor bridge, a diode bridge, a dual converter, a half control thyristor. Yes, right. Dual converter. Answer is dual converter. See, DC shunt motor drive, for a DC shunt motor requiring motoring in both the direction and braking on both the direction, a dual converter is required. A dual converter provides 4-quadrant operation. Formula or concept used. 4-quadrant means forward motoring, forward braking, reverse motoring, and reverse braking. So dual converter we use. And in dual converter, this formula is very, very important. Alpha 1 plus alpha 2 equal to 180 degree. This is also very, very important. Next, sixth question. In a commutation circuit employed to turn off an SCR. SCR means silicon controlled rectifier satisfactory. Turn off is obtained when circuit turn off time greater than device turn off time, circuit turn off time, circuit time constant, okay, time constant is greater than device turn off time, circuit turn off Circuit time constant less than device turn of time. Circuit turn of time less than device turn of time. What is your answer? Purna, second, circuit time constant. Circuit time constant greater than device turn of time. Any relation between the circuit time constant and device turn of time? Purna, please care about it. Guru Kanishta. Yes, yes. Right, beta. Guru Kanishta, you are right. Yes, beta. Because what is the relation between the circuit turn of time and device turn of time? This circuit turn of time equal to safety factor times of device turn of time, dear, and safety factor always greater than equal to 1. So for successful commutation, TC greater than equal to TQ. Okay, this is our right answer. So circuit turn of time is greater than device turn of time. Okay, this is our answer. Simple theoretical question, and this is the relation for successful turn off of SCR. The circuit keep the SCR reverse bias for the time greater than the device turn of time. Formula use TC greater than TQ, where TC is the circuit turn of time and TQ is the device turn of time. Therefore, circuit turn of time greater than device turn of time. Next, seventh numerical question. See, this is the new question. Okay. Wall power rating of converter circuit is given by the product of. This is the new question. Lokesh. Yes, A answer. This is the new question here in power electronics. Okay. We write all the important things here. Okay. Wall power rating of converter circuit is given as PIV into RMS. Okay. Where PIV peak inverse voltage, IRMS equal to RMS voltage. Peak inverse voltage. What is the option here? See. Peak, yes, peak inverse voltage and IRMS value. This is the very important question, not frequently asked question, rarely asked question. So please remember this. Next, eighth question. This is also very important, but this is not directly from the power electronics. Okay, this is from the drives. Optocouplers are connected to transistor. And this is the question from the communication. Okay, optocouplers are connected to transistor. So leave it. This is question from the miscellaneous concept like communication and all. Leave it this. Ninth question. See, a thyristor based half wave. This is important for you. Half wave rectifier. Okay, thyristor based, not the diode. Is supplying a resistive load. This is very simple circuit for the resistive load. The source voltage root 2 Vs cos, root 2 Vs or Vm cos omega t, both are same things. Okay. If the firing angle alpha equal to 60 degree, the average load voltage means average output voltage. Tell me. What is the average output voltage? Use the formula and this is the very beauty of this exam. Means not ask the value in the decimal or the integer form, only ask the fraction form. This is very beauty of this exam. Okay, बहुत ही. Okay, Lokesh, tell me. Gurkanishta, Purna, what is the answer of this question? see what is the formula we use? VO average, because this is half wave rectifier. So V max upon 2 pi 1 plus cos alpha. This is our formula. Okay, here we not discuss the derivation and all. Okay, here we discuss the what type of question, what are the difficulty level of this exam, and this is the not the very simple. This is the easy to moderate. Okay, because certain questions are uncertain. Okay, see one. Okay, see, apply the value V max. What is the V max here? This root to Vs, the multiply, when we multiply the any term with the sine, cos, sine omega t, cos omega t, or we can say coefficient of cos omega t, sine omega t are the peak value. So V max equal to root 2 into Vs. This is the important things upon 2 pi. Okay, and 1 plus cos alpha, and alpha equal to 60 degree, and cos 60 degree equal to half. Cos 60 is the half and 1 3 by 2 root 2 by Vs over 2 pi. This is cos 60 half and 3 by 2. Okay. So what is the formula? 3 pi 3 root 2 over 4 pi. Yes. 3 root 2 over pi. Yes. 3 root 2 Vs over 4 pi. This is our answer. 3 root 2 Vs upon 4 pi. Tell me, any doubt? Guru Krishna, yes, beta, yes, you are right. Good. Very good. Tell me, this is the simplest numerical, na? Formula wise only. Okay. And question asked in the fraction format. If this question options are in decimal or integer value, approximate, when we solve this root 2, 4 pi and all, and this is complex, then question become difficult side. See, this is the solution of same question. Next, this is also important. Yeah, this is the AC voltage regulator. How you can say this is the full wave AC voltage regulator? Because here symbol is diode, but here mention alpha equal to 90 degrees. That is why this is SCR, not the diode. Tell me. In the figure shown below, a thyristor based one phase voltage regulator with a firing angle alpha equal to 90 degree, the RMS output voltage is. What is the RMS output voltage? Solve. Another option is VSY2. Third root 2 Vs by pi, and Guru Kanishita. Okay. See beta, what is the RMS voltage? VOR means output RMS voltage. VM means maximum value upon under root 2T naught. This is very, very important. 2T naught in bracket, and this is limit alpha to pi na. So upper limit minus lower limit plus 1 upon 2 sine 2 lower limit minus sine 2 upper limit. This is the shortcut. Okay, and this is whole power 1 by 2. So we putting all the value. Vm is the V max, and what is the time period? Pi, because this is the full wave. So 2 pi. Okay guys, upper minus lower, upper limit is the pi and lower alpha, pi minus alpha plus 1 upon 2 sine 2 lower, sine 2 alpha minus sine 2 upper, sine 2 pi. Sine 2 pi or any pi is 0. And this is okay. This is the small bracket. This is power half. Solve Vm. But answer in terms of C. Okay. Not worry about this. 2 pi. And this pi minus alpha. Alpha is the, what is the value of alpha? 90 degree. So in place of alpha we put pi by 2 because 90 degree is in degree, but here we put the value because pi minus something, that pi is in radian, then alpha is also in radian. Plus this is 0, sine 2 alpha by 2, sine 2 alpha. Sine 2 alpha is the 90 degree, sine 2 alpha, and this 1 by 2 we put here. This. When putting the value of alpha 90, then 2 into 90, 180, and sine 180 0. So this term also 0. And last, Vm upon root 2 pi into this pi minus pi by 2, that is pi by 2. Okay, this pi by 2. What is the Vm? Vm is the maximum value, means the coefficient of sine omega t root 2 Vs is the Vm. Root 2 into Vs over root 2 pi into pi by 2. So, what is the answer in format? See, this Vs into pi upon root 2, and here root 2 also separate, root 2 pi also and 2 also. Then root 2 cancel out, and this is pi. Oh, sorry guys. This is in square root, na? This is in square root. So sorry. We write again. This is in square root. So in place of Vm, we put the maximum value, root 2 Vs over root 2 into root pi. We separate the value, and this is root pi. This is also root 2. Root pi cancel out, root 2 cancel out, then we get Vs upon root 2. Okay, Vs upon root 2. Vs upon root 2, second answer. Tell me, beta, any problem in this question? Simplest. Value are simple because 90 degree. This is our question. Please see again. This is our question. And with the help of this data, we proceed like this. Tell me, any doubt in the solution or in any concept? Vsy root 2. Okay. Please thumbs up. Please thumbs up if you not face any problem in the question. Please thumbs up so that we understand you face no problem and we go ahead. Please confirm me and thumbs up. Yes. Next. This is our solution in the typing format. See, this is from the chopper circuit and this is clear, sir. Okay, beta. Thank you. Please try this. In DC chopper, per unit ripple is maximum when duty cycle alpha is. Tell me answer. What is the duty cycle? See, duty cycle, we write all the concept. And this is the DC chopper. Duty cycle, D or alpha equal to on period of the switch upon total time period. This is the duty cycle. Generally, if a converter is not mentioned, buck boost or buck boost, we assume buck converter. Ripple current, ripple current, ripple current ripple current in chopper circuit, in chopper especially buck converter or step down chopper. What is the ripple current formula? Delta I L, because we study the ripple in the inductor current. D 1 minus D Vs upon Fl, or we write as D multiply inside D minus D square Vs over Fl. Okay, this is equation number 1. And also we write the alpha. So alpha minus alpha square Vs upon Fl. For maximum ripple, maximum ripple, di by dd means differentiation of ripple current with respect to duty cycle is 0. When we differentiate d minus d square, we get 1 minus 2d, and all the terms are constant. Vs upon Fl equal to 0. So 1 minus 2d equal to 0 and d equal to 0.5. This is our final answer. D or alpha, both are same thing. Same means a different symbol, the same quantity, alpha or D. Okay. So this is our derivation, small derivation. Okay. And you directly remember the 0.5 answer. But this is important. Okay. 0.5. Yes, beta, yes. But if we want to determine the corresponding maximum ripple, delta IL maximum, then we put the value in the delta IL, which is D 1 minus D Vs upon Fl, and we put D equal to 0.5 here. Then we get the maximum ripple. Putting D equal to 0.5 and 1 minus 0.5, that is 0.5. This is the Vs over Fl. Then 0.5, 0.5, 0.25, and this is we write as Vs upon 4Fl. This is the maximum ripple. If we increase the frequency of the switching or value of the inductance, then this ripple minimized. This is the important question related to that particular concept. How we can minimize the ripple in the chopper circuit? So we can increase the value of the switching frequency. Okay, that is why we use the MOSFET, because MOSFET is a high speed on off switch. Next, this is our other solution in the typing format. Tell me, beta, if you face any problem. Next question, this is set 1, Andhra Pradesh Transco. Okay, tell me, for an SCR during turn on and turn off, the quantities responsible respectively. Very simple question in the power electronics. Tell me. Turn on means latching current, turn off means holding current. Simple na yaar. Respectively, turn on means latching current, turn off means holding current. Next, this is the definition of the latching and holding current. Okay. Next, simple numerical, yeah, simplest question. See, a particular power electronic controller develops a symmetrical output voltage from pi by 6 to pi radian and 7 pi by 6 to 2 pi radian across a resistive load. Over a cycle, the circuit contains a triac. Very simple, yeah. Very simple question, theoretical question. Okay, power electronic controller, see, pi by 6 to pi and 7 pi by 6 to 2 pi. This means the output is controlled symmetrically in both the positive and negative half cycle. Such symmetrical phase control of AC voltage is obtained using a triac. A triac conducts in both the directions and is equivalent to two SCRs connected in anti-parallel with a common gate. Okay, this is the description of the question. See, single phase, this is also very simple. Yes, beta, yes. A single phase midpoint full wave SCR converter, single phase midpoint full wave SCR converter with maximum midpoint voltage of Vmax volt develop an average output voltage across resistive load at firing angles of 0 and pi by 2 radian respectively. Okay. Single phase full wave. What is the average output voltage formula? And putting in the formula alpha equal to 0 and then alpha equal to pi by 2. Yes, see, VO average equal to, for because this is the full wave. So VM means maximum value upon pi 1 plus cos alpha. 1 plus cos alpha, putting all the value. Vm is the Vm, that is the maximum value. So case 1. Case 1, alpha equal to 0 degree. So VO average equal to Vm over pi 1 plus cos 0 and cos 0 is 1. 1 plus 1 2 Vm upon pi. So VO average equal to 2 Vm over pi. It act as a diode. 2 Vm upon pi, 2 Vm upon pi, 2 Vm upon pi, 2 Vm upon pi. Yes, only one answer is. So we solve case number 2 also, because this is the concept understanding session. Alpha equal to 90 degree. So VO average equal to Vm over pi 1 plus cos alpha. Alpha is the 90, then cos 90 equal to 0. Cos 90 equal to 0. So Vm upon pi. VO average equal to Vm over pi. Okay, guys, this is our answer. So 2 Vm over pi, comma Vm over pi. Yes, V max is Vm. Okay, we use the maximum voltage as a symbol Vm. This is also simplest numerical. This is a typing format solution. See, a 240 volt 50 hertz single phase half wave SCR converter supply a resistive load at a firing delay angle of pi by 3. Pi by 3 means 60 degree. The RMS load voltage single phase half wave. Okay, RMS output voltage VORMS equal to, we apply the short formula 2T naught Vm upon 2T naught. Here T naught is the time period 2 pi. Okay, in bracket upper minus lower pi minus alpha. Okay, plus 1 upon 2 sine 2 alpha. This is our answer. Putting all the value, this is the 230 volt RMS value, and RMS value we put here maximum value √2 into 240. 240 divided by √2 into √2 into √pi. We separate all the terms. Okay, we separate all the terms. Next, pi minus pi by 3. See, pi by 3, yes. Plus 1 by 2 sine 2 alpha. Sine 2 alpha. This is the 60 and 60 to the 120. 120. Half power. Okay. So what is the solution? Okay. Sine 120. Sine 120 means sine 90 plus 30. 90 plus 30 means second quadrant sign is positive. This is the 90 plus, that is cos 30. Cos 30 equal to √3 by 2. Yes. This √2 cancel out. 240. Okay. 240 √2 cancel out. This is 2 and this is √pi. And in the bracket, this is 3 pi minus 2 pi. 3 pi minus, this is 2 pi by 3. Okay, guys, plus. And this is sine 30, cos 30. Cos 30 is the cos 30 √3 by 2. √3 by 2 and 2 already, that is 4. So we, and this is under root. Match the answer. Okay, if we this in the outside pi is not mentioned, we put in inside 240 divided by √2, and when √2 inside the square, inside the square root, then this make the square. 2 pi by 3 pi plus √3 by 4 pi 1 by 2. Okay, so 240 divided by √2, and this is 2 by 3 plus √3 by 4 pi 1 by 2. Okay, so what is the problem here? Pi minus alpha, 1 minute. Pi minus alpha, alpha is the pi by 3. So pi by 3, 3 pi minus 2 pi, 2 pi by 3. Yes, 2 pi by 3, 2 by 3, 240 by √2, 240 by √2, 240 by √2 and 240. Yes, what is the problem? See, yes, 1 minute. Here the time period. Time period is the, this is the single phase half wave. Time period is the 2 pi. Okay, 2 pi. What is the 240 upon √2? 5 by 6. 5 by 6 or 5 by 12. Why 5 by 6, yaar? It is the formula Vm upon under √2t naught. Time period 2 pi, pi minus alpha. Okay, plus 1 upon 2 sine 2 alpha. Okay, these terms are right. Okay, see the solution. I think this question is wrong. So yes, but in the B, yes, solution is our also. VRMS equal to B option. See again, B option. 5 by 6. Actually, this is typing error, yaar. Okay. See, beta, this is not a. None of the above. Okay. None of the above option, because B option is the 5 by 6. but right answer is 2 by 3. We solve all the things, na? Okay, and this is correct approach, and this is the right answer. So not a none of the above. And this is, we take the question from the official side. Okay, so this question are objectionable because none of the option match. Okay, beta. And here also the solution. Okay, here we derive the formula, and this 2 by 3. Yes, beta, this is also right. Okay, and our solution also right, but given option is not matched. Please try. A single phase half wave controlled SCR converter with a commutating diode supply an RL load, okay, at an average load voltage of 150 at an firing delay angle of 60 degree. The supply voltage to the converter is single phase half wave. Tell me. See, single phase half wave. So what is the average output voltage formula? Vm maximum value upon 2 pi 1 plus cos alpha. Putting all the given value, VO equal to 150 volt equal to, this is the maximum, 2 pi 1 plus cos alpha. Alpha is the 60 degree, and cos 60 equal to half, and this 1 plus half root 3 by 2, sorry 3 by 2, and this is 150. So what is the value of Vm? Vm equal to 150 into 2 pi into 2 divided by 3. Okay, so Vm equal to 50 into 4 into pi. So this is 200 pi, and this is the maximum value, and we supply RMS equal to max upon root 2, max 200. We write 100 pi into 2 and 2 root 2 into root 2. So divided by root 2 cancel out. Then we get 100 pi root 2. See, 100 pi root 2. 100 pi root 2 is not mentioned. It means in the question, maximum value of the supply voltage is asked. So our answer is Vmax, which is 200 pi. So C is the right answer. If both the option is given, then we select the RMS value. Okay, by default we give the answer in the RMS value. Okay, this is our solution. See 17, question number 17. For a DC to DC boost converter circuit, the order of the DC to DC boost converter, not the buck, this is the boost. Order of connection of component LCD MOSFET switch in between supply and the load from left to right. We draw the circuit of boost converter. This is the inductor. This is the switch or MOSFET, because here mentioned MOSFET. This is the diode. This is the capacitor, and this is our load. This is the boost converter circuit diagram, VS. This is the inductor, this is the MOSFET, this is the diode, this is the capacitor, this is the load. And from left to right, which component? From the supply, between the supply and load, L, MOSFET or switch, diode, L MOSFET DC, L switch in series, no, L switch in parallel, yes, then diode series, yes, C parallel, yes. C is the right answer. Okay, this type of question also asked in the examination. Next, please try. In a DC to DC buck converter, when MOSFET switch is triggered, the rate of change of current in the 400 microhenry inductor L is ampere per second. If the converter is operated with input voltage, the output voltage of the converter. What is the? I have been requesting you for a long time, but you are not listening. Why? I had also told you about GPSC EEE, but they said that they will share it, but I have not received it yet. But which you received and not, tell me. I have been requesting you for a long time. Where, beta? Struggle student. Tell me, beta, what is your problem? Please tell me. I am commenting in Hindi. One minute. I am commenting in Hindi. PYQ questions paper PDF. Where you commenting, beta? Here we discuss the previous year questions, and here you not ask any doubt related to this concept. After completing the session, we share this PDF also. Okay. PYQ पेपर PDF शेयर कीजिए आप जीपी का PYQ अभी शेयर कर दूं बेटा, सेशन छोड़ दूं बीच में स्ट्रगल स्टूडेंट, बोलो सेशन बीच में बंद कर दूं मैं, पहले क्वेश्चन से आपको शेयर कर दूं, बताओ बेटा। अभी आप क्वेश्चंस पर ध्यान दीजिए ना, उसके बाद में अगर आप मुझे कांटेक्ट करते हो या कोई भी आपका डाउट है तो मैं हमेशा अवेलेबल हूं। अभी तो हम सेशन कंडक्ट कर रहे हैं ना, तो आपको सेशन पर ध्यान देना चाहिए बेटा। ये सारी चीज छोड़कर पहले पेपर ईयर आपने कहाँ मैसेज किया बेटा? देखो ये सेशन जो चल रहा है ये आपका क्वेश्चन सॉल्विंग को लेकर है, यहाँ आपने ऐसा कोई डाउट पूछा नहीं, कुछ नहीं, तो मैं जो रिलेवेंट थिंग्स होंगे जो कि अभी हमारा पर्पज है उस पर ही तो ध्यान दूंगा ना। स्ट्रगल स्टूडेंट्स 7700 टेल मी। Okay, so why you are telling here I have been requesting you for long time? But this is not the way. Okay, here we discuss all the PYQ questions. If you face any difficulty in any questions, any concept, then you will discuss. Okay, also see, what is the average output voltage? Change of current in the 400 microhenry inductor. This is buck converter. So L equal to 400 microhenry, 400 into 10 to the power 6 Henry, and di by dt equal to 7.5 into 10 to the power 4 ampere per second, and V in is the 50 volt. For buck converter, VL equal to V in minus VO when switch is on, and also VL equal to LDI by dt, putting the here. Okay, so we write this here so that you easily understand the concept. See, VL equal to Vs. Vs is the supply voltage minus Vo. When switch is on, when switch is on, okay, and VL equal to L di by dt, L di by dt equal to Vs minus Vo. Putting all the value, what is the value of the inductance? 400 microhenry. 400 micro means 10 to the power minus 6 di by dt. What is the value of di by dt? 7.5 into 10 to the power 4. 7.5 into 10 to the power 4, we see again 7.5 to 10 to the power 4, yes, equal to, what is the value of Vs? That is the supply voltage operated with a 50 volt input voltage, and this is average output voltage. So 10 to the power 4 and 10 to the power minus 6 and this 10 to the power 2 cancel out. We cut this and 2 0 cancel out. So this 4 into 7.5, 7.5 to the 15 and 15 to the 30. So VO equal to 50 minus 30. So VO equal to 20 volt. Okay, this is our, and so 20 volt is the right answer. Okay, if you are not able to understand my comments properly, then what am I saying? I am saying in Hindi. Yes, beta, struggle student, we will share after the session. Okay. Okay. Next. See, a separately excited DC motor controlled by a single phase SCR full converter supply at 200 volt AC voltage draws 40 ampere at a firing delay angle of 45 degree. If the armature resistance of the motor is 0.25 ohms, the back EMF is. Okay, beta. See, single phase fully controlled SCR converter, supply voltage 200 volt, firing angle alpha equal to 45, armature current IA equal to 40, R equal to 0.25 given in the question. Formula used, VDC equal to 2 Vm over pi cos alpha. This is for highly inductive load. V in equal to root 2 times of Vs, and AB, that is the back EMF, equal to VDC minus IARA. V in equal to root 2 200 VDC, we apply here, and this is comma here. VDC equal to this and VDC equal to 400 by pi. Armature voltage equation, VDC equal to AB plus IARA and AB equal to VDC minus IARA, AB equal to this. So AB equal to 400 pi minus 10 volt. In an adjustable speed DC drive operated by an AC to DC converter, means rectifier unit, with armature voltage control up to base speed. Up to base speed. Okay, struggle students. Okay, beta. Answer the 20th question. And this question is related to drives. In an adjustable speed DC drive operated by an AC to DC converter with armature voltage control up to base speed. Torque remain constant, increase in speed. Yes. This is the concept. EV equal to K phi N, T equal to K phi I. This is the general expression in the machine. Okay. If armature voltage control, the motor operate in the constant torque region up to base speed. So as speed increase by increasing the armature voltage, the torque remain nearly constant. Okay. So C is the right answer. See this? A triac in a single phase circuit taking V volt and operating at a firing delay angle alpha is supplying a resistive load R. The power loss in the load is, first of all, determine the RMS value and then find the RMS value V RMS square by R. Standard formula yaar. V RMS square by R, pi minus alpha. Okay. D is the right answer. Simple. Because V RMS equal to V upon under root pi minus, no. This pi minus alpha, not the pi plus alpha. This is not the correct. Correct is C. Okay. Because this is, we use plus here minus. Okay. So C is the right answer. Directly formula wise. Okay. This is, so V RMS equal to this, V RMS square and power equal to V RMS square by R. Then we get this formula. See, in a boost chopper circuit, if Vs and Vo are L are input voltage, output voltage and inductance respectively, when the conducting switch is open, the rate of change of inductive current. See, boost chopper, when the conducting switch is open, in a boost chopper the inductive voltage VL equal to Vs minus Vo, and in place of VL we put L di by dt. Okay, L di by dt equal to Vs minus Vo. So di by dt equal to Vs minus Vo upon L. So this is our right answer. C is the right answer. 23rd, in a three-phase converter circuit during the commutation, when one SCR is one phase turn on to turn off an SCR in another phase, results in voltage notching, harmonic distortion, voltage sag, or voltage swell. Tell me. This is voltage notching. Yes. See, this is the explanation. During the commutation, when one SCR is turned on to turn off another SCR in different phase, the supply lines is momentarily short circuited through the conducting SCRs. This causes a dip in supply voltage, which is called voltage notching. A snubber circuit is connected to power semiconductor device to reduce. Tell me. This is very simple question. Electrical stresses or dV by dt triggering. Okay, this is the explanation. Next. Which phenomena is present in a thyristor but absent in BJT, MOSFET and IGBT? Tell me. Which phenomena present in thyristor? Forward conduction, latching, forward blocking, reverse breakdown. This is also simple question. Tell me. Which is the right? Struggle students. Tell me the answer. Yes, latching. This is related to SCR, na? 26. In an adjustable speed AC drives is very, very important. Most of the question asked from the drives. In an adjustable speed AC drive, which quantity gets reduced above the rated speed? Developed torque. Okay, developed torque. This is the explanation. Above rated speed, the motor operates in the field weakening region. In this region, voltage remains constant, frequency increases and flux reduces. Since T proportional to phi A, when flux reduces, developed torque also reduces. Developed torque. Okay, so our answer is A. 27. RC triggering is preferred over resistance triggering because, what is the reason? Yes, for larger angle of alpha. Enable triggering at a larger value of firing angle. Yes. Because resistance firing circuit applicable up to 90 degree of firing angle. Next. This is 2014 questions. The main advantage of IGBT over SCR in power electronics. Tell me. Yes, self-commutating property. Advantage of IGBT. An SCR is a line commutated device, so it cannot be turned off by the gate signal. And IGBT is a self-commutating device, so it can be turned on and off by the gate signal, self-commutating capability. And GTO also, but here question related to IGBT over SCR. So we put the answer accordingly. Next, in a two-pulse bridge converter with a freewheeling diode, okay, the width of the diode current pulse over one cycle is alpha is the firing angle. Tell me. Yes, 2 alpha. 2 alpha. Okay, this is the explanation. See, if you face any difficulty in the conceptually or numerically, then put this problem in the comment section also. Okay, if any students see the session after the live, a 440 volt 3 phase 10 pole 50 hertz synchronous motor delivering torque of this deliver power. This question is the machine, okay, from the machine. Okay, so power equal to T into omega. First of all, we determine torque is given, and first of all we determine the omega 2 pi ns by 60. Okay, so torque equal to 50 by pi, and omega is the 2 pi 2 pi n 2 pi n is the 120 f by p, 2 pi n by 60 120 f by p is the number of poles. Putting all the values here, 50 upon pi 2 pi into 120 into f, and frequency mentioned. If not mentioned, we take the 50 hertz. Mention 50 hertz. Then 60 into p, number of poles. Number of poles are 10. Okay, so 60, this is the 2. Okay, then what is the answer? Pi cancel out. Okay, and this is 62. 2 to the 4 into 50. Pi cancel out, and this is 10. 10 0 is okay, 20 whole 0 10 watt, 1000 watt. Yeah, 1000 watt. Tell me any doubt in the question? P equal to T into omega. Simple. This question from the machine, not the power electronics. Okay, so 1000. Yes. 31. A PWM switching scheme is used with a 3-phase inverter to reduce the total harmonic distortion with modest filtering. Yes. Minimize the load on the no. Reduce the lower order harmonic and increase the higher order harmonic. See the question and tell me. Yes. Fourth is the right answer. Reduce the lower order harmonics. Next, the synchronous reactance. This is also from the machine. Reactance due to the armature reaction of the machine. No. Reactance due to the leakage flux. No. Combined reactance due to the leakage and armature. Yes. XS equal to XAL plus XAR. Na? So this is the simple question from the machine. Okay. XL plus XA. Next. The latching current of T1 is 1 milliampere. The minimum width of gate pulse required to turn on SCR. These type of questions are very important. Solve. See, latching current. Latching current means minimum current required to turn on the SCR. First of all, we assume the SCR, that is thyristor, are short circuited. Then voltage across the SCR A or inductor V equal to LDI by dt. Okay. So VL, when this is the short circuited, okay, then output voltage or voltage across the inductor is 200. Okay, so we determine the value of the current. So DI equal to 1 upon L VL dt, integrating both sides. I equal to V L upon L into T. Putting all the value, VL equal to 200 upon L. L is the 0.2 and latching current 1 milliampere. 1 milliampere into 10 to the power minus 3, and we want to determine this T, and T equal to 0.2, okay, 0.2 into 10 to the power minus 3 divided by 200, and 2 to cancel out, then this is 0.10 to the power minus 3 into 10 to the power minus 3 is 10 to the power minus 20, okay, this is 10 to the power minus 6 second T, or we can say T equal to 1 microsecond. This is the pulse width, 1 microsecond. This is the right. And this is the standard question in the power electronics. See, 34, and this is from the 2012. A single phase fully controlled rectifier has an average output voltage of this. Single phase fully controlled, okay. When alpha equal to 0 degree, its output voltage when alpha equal to 30 degree. See, VO average equal to single phase full control, Vm over pi 1 plus cos alpha. Case 1, VO equal to 200 volt when alpha equal to 0 degree. Putting in the above expression, 200 equal to, here we determine the Vm, 1 plus cos 0, and cos 0 is the 1 plus 1 2 Vm over pi, 2 Vm over pi, this is implies Vm equal to 100 pi, okay, 100 pi. Now case 2, VO equal to Vm over pi 1 plus cos alpha, and what is the cos alpha? And in the second case, alpha equal to 30 degree. Vm is the 100 pi divided by pi 1 plus cos 30, and cos 30 equal to, cos 30 is root 3 by 2, pi cancel out, then 1 plus root 3 by 2, okay, root 3 by 2. When we solve this, 173 volt, okay, so approximately 173 volt. Simple. With the help of first case, first of all we determine the Vm and put in the second case. See, a 200 volt DC to DC converter, means chopper circuit, is turned on for 30 microsecond and off for the second, the average output voltage. But here not mentioned buck or boost, so we assume the buck converter or step down chopper. So first of all we determine the duty cycle, T on upon total time. So what is the on time? 30 microsecond, and total on plus off, and off is 10. So this is 3 by 4, okay. And what about the average output voltage? VO equal to dVs. D is the duty cycle, V is the input voltage. So D is the 3 by 4 and Vs is the 200. So what is the answer? 50, 53 is a 150 volt. 150 volt. Okay guys, this is our simple numerical. Next, in single pulse modulation used in PWM inverter for eliminating third harmonic component in the output voltage, the pulse width. First of all, we determine the harmonic analysis, harmonic voltage, VON equal to N equal to 1, 3, 5 up to infinity, okay, 4 VDC upon N pi sine N pi by 2 sine ND into sine N omega naught T. For eliminating the third order harmonic or any order harmonics, sine and D we derive general condition equal to 0 means ND equal to M pi, M equal to 0, 1, 2, 3 and so on. So D equal to, putting the M equal to 0, 1 pi y n, n divided 2 pi y n, 3 pi y n, 4 pi y n, 5 pi y n and so on. And 2D equal to 2 pi y n, 4 pi y n, 6 pi y n, 8 pi y n, 10 pi y n and so on. And 2D always less than equal to pi or 180. Okay. So if we want to eliminate the third harmonic, third or fifth, eliminate third order, putting n equal to 3, then 2 pi by 3 less than the pi or 180, then this is required pulse width. So required pulse width equal to 2 pi by 3. 2 pi by 3 radian, or we can say 2 into 130, that is 120 degree. Okay, 120 degree. This is the right. This is the mathematical procedure. Next. So this is our questions for your previous year questions on the power electronics. Okay. If you face any difficulty in any question, then put this problem on the comment section. Okay. And we take another session on these type of doubts. Okay. Okay, beta.